Welcome back to the deep dive. Today we're undertaking what really feels like a fundamental reorientation of reality.
That's a good way to put it.
We are plunging into this dense stack of sources. We've got white papers, some pretty deep philosophical texts, and even these high-fidelity simulation physics models.
And they're all tackling one central, massive question.
How does order maintain itself in a universe that is, constantly trying to fall apart?
It's an elegant stack material because it shifts the fundamental focus of how we even view organization. We're so used to thinking in terms of forces, pushes, pulls, big signals.
Right, the obvious stuff.
Exactly. But this material suggests that the real organizing principle is much, much subtler. It's constraint. It's the art of limiting possibility, the silent architecture that prevents chaos.
And that's the mission right there.
Okay.
Our goal today is to understand how constraint, this whole process of setting a non-negotiable boundary, is the key operating system across these wildly different domains.
It really is. We're going from the nearly invisible, the nanoscale mechanics of the human brain.
All the way to a unified theory of cosmology and, well, consciousness itself.
So to give you a quick roadmap, first, we're tackling a pretty controversial biological question. It's this debate around biogenic magnetite in the human brain. Is it just inert trash, or is it a subtle regulatory constraint?
Then we move to the digital realm.
Yeah, we'll analyze the elegance of the TechCraft simulated universe, which is amazing. It generates massive complexity from just 3 fundamental laws. It's all about constraint.
And finally, we zoom out further than we've ever gone before. We're going to immerse ourselves in the ceneezer synthesis, which is this metaphysical unified theory that maps the laws of physics directly onto the dynamics of human consciousness, desire, and, well, error.
It's a journey that asks us to look past the visible motor, the engine doing the work, and focus instead on the essential frame that holds it all together.
Okay, let's unpack this. All right, so we're starting with this massive debate in neurobiology that feels almost, custom designed to illustrate our theme today, constraint versus force. We're looking at biogenic magnetite, FACE. It's a mineral, basically a tiny natural magnet, and it's found in human tissues that have no obvious need for it.
Specifically the brain and the meninges.
The meninges, right, the protective membranes around the brain.
And the finding itself, that's not contested. The nanoparticles are there. They're chemically consistent with being made by the body. The whole controversy, it's all about what they do.
So what's the classical view, the established take on it?
The classical empirically conscious view says this stuff is metabolically incidental. It's a side effect of iron metabolism. Just some chemical baggage. Inert. Meaningless.
And the classical objection to it being functional is, from what I've read, extremely robust. This is why the debate is still going.
Oh, absolutely. It's rooted in very sound, very conservative physics. The main argument is that these particles are just. They're too weak to matter. The magnetic forces they could possibly exert are completely overwhelmed.
Overwhelmed by what?
By this constant chaotic onslaught of energy that we call thermal noise.
Thermal noise. Okay, let's get a handle on that.
Think of it as the ultimate molecular mosh pit. At body temperature, molecules are moving, they're vibrating at extremely high random speeds.
So it's just chaos at the microscopic level.
Total chaos. And these rapid fluctuations, that's literally the heat in your body, they deliver far more energetic kicks to everything around them than the minuscule, persistent tug of a nanoscale magnetic particle could ever deliver.
So if the magnetite is supposed to be a sensor or an actuator, it's like trying to guide a battleship with a feather duster.
In a hurricane, yeah.
In a hurricane. The signal-to-noise ratio is it's impossibly low.
Right. And so the burden of proof for anyone claiming it's functional is extraordinarily high. They need to show organization, which we don't see in humans, not like in migratory birds. They need to show quantity. And, most critically, they need a physical coupling mechanism strong enough to overcome that massive energy from thermal noise.
And if you don't have that, the default conclusion is...
It's irrelevant. It's noise.
But this is precisely where the constraint hypothesis enters the ring. And it's not arguing with brute force, it's arguing with, I guess, theoretical elegance.
It is. This view comes out of complexity science, information theory, and it suggests that our mainstream focus on actuators is a systemic blind spot. We are always looking for the thing that pushes the system.
Instead of the thing that guides it.
Exactly.
Yeah.
And to accept this, we have to fundamentally reframe what information even is.
Okay.
Information isn't defined by signal strength. It is defined by a reduction in uncertainty. So if a complex biological system, like a neural network, It has a million possible configurations it could adopt in the next second.
Right.
And a small, persistent influence narrows that down to, say, 900,000 possibilities. That is a genuine gain in information, regardless of how much energy was involved.
So you're defining information as the setting of a boundary. That dictates the trajectory. I really like that phrasing. It's the core of this whole deep dive.
It's the difference between forcing water down a path and just
Yeah.
building the riverbank.
The riverbank doesn't have to push every molecule of water. It just has to exist persistently.
And this leads us to the critical conceptual breakthrough about thermal noise. The constraint doesn't overcome the noise by strength. It overcomes it by time, specifically through something called memory hysteresis.
Hysteresis. Okay, let's make sure we ground that term. What does memory hysteresis mean for these little nanoparticles?
Hysteresis is a property of systems where their current state depends not just on what's happening to them right now, but on their history. They have memory.
Okay.
So in a magnetic particle, a weak external magnetic field, maybe from some neurons firing nearby,
Yeah.
it might subtly align the particle's magnetic moment. But then thermal noise immediately tries to shake that alignment back into randomness.
But because it's a magnetic material, it holds on to a little bit of that alignment even after the influence is gone. It retains a subtle memory.
Precisely. The particle acts as a tiny temporal integrator.
Mm.
Instead of trying to fight the chaos of thermal noise second by second, which is impossible,
Right, you can't win that fight.
you can't. So instead, the particle stores and sums these small probabilistic biases over very long timescales.
Mm.
The thermal noise is rapid and random, so it cancels itself out over time. But the subtle directional bias from the local biology that gets integrated, it accumulates.
So the magnetic alignment provides a persistent physical path for encoding order against the quick, erratic spikes of thermal energy. That's an incredible shift in perspective.
It is.
You stop asking, is the force strong enough to win the second? And you start asking, is the particle's memory good enough to integrate these tiny biases over a minute or an hour or a lifetime?
That accumulation is the mechanism. It's how a weak, non-energetic constraint can dominate the outcome over time. And this brings us to the anatomical plausibility. If it's doing something, it's not a traditional sensor. It has to be a structural regulator, a context setter.
And I really appreciate that the source material grounds this idea in, historical biological context. We've made this mistake before. We dismissed glial cells as just packing material, the glue of the nervous system.
Until we realized they manage the entire ionic and nutritional environment. They're critical.
Or we called non-coding DNA junk DNA before discovering its crucial regulatory role in turning genes on and off. The constraint layers are often the last things we recognize.
And the magnetite hypothesis proposes exactly that. It's probably located in or next to these critical regulatory areas, maybe inside the glial cells themselves or in the meningeal layers that deal with cerebrospinal fluid. These areas are known to regulate the macroenvironment of the entire brain.
So instead of thinking about a magnetic field triggering one single neuron like a strong, explicit signal, we should be thinking about it subtly shaping the entire environment. Is that it?
Yes. The proposed mechanism is that the magnetic material alters the local magnetic susceptibility, and that, in turn, could constrain the geometry or the stability of local electric fields. This ties into something called ephaptic coupling.
Okay, let's pause there. Ephaptic coupling. For our listeners, we usually talk about synaptic transmission, chemicals jumping across a gap. What is ephaptic coupling?
Ephaptic coupling is basically electrical communication that happens outside the synapse. It's where the electrical activity of one neuron subtly influences the electrical environment of its neighbors. It can bias them toward or away from firing, but without any direct chemical link.
So it's field-based communication.
It is.
So the magnetite isn't a switch. It's a tiny, permanent filter that subtly biases this electrical environment. It doesn't tell a neuron to fire, but it makes it marginally easier for huge populations of neurons to fire together.
It sets the background coherence of the entire network. If you think about the brain's ability to synchronize millions of neurons, which is necessary for complex stuff like memory retrieval or high-level focus, the magnetite offers a mechanism to maintain that collective sync without constantly spending massive amounts of energy to enforce it.
The constraint minimizes the path toward collective order.
You got it.
But the skeptic in me, and I'm probably speaking for a lot of our listeners here, has to ask, why is this tiny magnetic bias necessary when we already have this hugely powerful, well-understood mechanism of synaptic plasticity? The strengthening and weakening of connections that governs all learning and coherence. Why do we need this extra layer?
That's an excellent question. And the answer from the constraint hypothesis is that synaptic plasticity governs the content and the pathway of information.
The specific thoughts.
Right. While the magnetic constraint governs the context and the stability of the overall network, synaptic plasticity is the programming. The magnetic constraint is the underlying operating system that stops the whole computer from crashing due to thermal load.
One governs learning, the other governs persistence.
I see. And this leads us directly to the falsifiable tests the source material proposes, which are designed to basically shut down this theoretical operating system and see what happens. The first test is an interference experiment. You tune WIC, external radio frequency RF magnetic fields, to specifically interact with the quantum effects of the magnetite, the electron spin states.
You're trying to scramble the particle's memory.
Exactly. If the magnetite is really functioning as a coherence setter, interfering with its microstates should immediately disrupt the highest levels of the system.
And what would you see? What would you measure?
You should see verifiable, immediate disruptions in things that reflect high-level synchronization, like specific EEG neurosynchrony patterns or global glial calcium signaling. If the system stays perfectly stable, okay, the constraint is inert.
But if you can turn off the system's coherence with a tuned, weak external field,
You've proven its functional necessity.
the second test is even more long-term, and it focuses on that idea of persistence.
This one involves developmental disruption. If the physical constraint from this material is fundamental to structural stability, then interfering with the iron crystallization pathways during early development.
So stopping the magnetite from forming correctly in the first place.
Right. That should lead to lasting, measurable deficits in complex psychological metrics.
And what metric would best reflect the loss of this structural persistence? What are you looking for?
The proposed metric is adaptive persistence. This is the capacity of your cognitive system to maintain complex, goal-directed behavior like holding a multi-step plan in your working memory, or just sustaining attention on one task over long periods, especially when you're facing distractions or entropy.
So if that structure is missing, the cognitive system should struggle to maintain coherence against external chaos.
That's the prediction.
The whole debate, then, it's really about how we choose to look at functionality. Are we only seeking the obvious energetic forces that cause things to happen, or are we prepared to recognize the silent, low-energy boundaries that make it possible for those things to persist?
It's a tension that demands critical thinking. And we have to ask you, the listener, if we insist on waiting for extraordinary proof of a strong force, does that empirical caution systematically blind us to the subtle, necessary constraints that govern life? Or is that standard of rigor the only thing stopping us from chasing biological noise?
That discussion about subtle boundaries defining the massive complexity of the brain is, wow, a perfect intellectual ramp for our next topic.
I think so too.
We are leaving the messy, wet world of biology for the crystalline elegance of the TechCraft simulated universe.
Here's where it gets really interesting. Because TechCraft is the ultimate controlled experiment in constraint mechanics. The developers weren't trying to build a perfect Newtonian simulation.
No, they were trying to do something else.
They were trying to build a universe where complex mechanical motion and self-assembly emerged deterministically from the fewest, simplest, and most elegant constraints possible. They basically replaced hundreds of individual force calculations with just 3 foundational laws.
It's a beautifully minimalist approach. They start by unifying everything under the law of universal balance.
And this one law, it governs gravity, heat transfer, and repulsion. And it does so purely by comparing 2 constraints. The tetrahedron's internal energy, let's call it aldelar, and the ambient temperature of space.
And that ambient temperature is just a function of how far the object is from the simulation's origin.
Exactly. Proximity to the origin and internal heat state are the 2 constraints that dictate absolutely everything.
So how does this fundamental energy difference give rise to something as complex as gravity?
It creates what they call emergent gravity. If a tetrahedron is cold, its internal energy is low, and it's pretty far from the origin where the equilibrium temperature is also low. The resulting energy differential is strongly negative.
And that negative value is interpreted as?
A powerful attractive force, pulling the object back toward the center of the universe. They call it reverse gravity. It's attraction driven by a desire for energetic equilibrium with the core.
And if an object is cold and far away, it's going to move quickly, which should heat it up.
Exactly. The action of movement itself, when it's moving away from its equilibrium point, causes energy flow, or what they term bleeding. Conversely, if a tetrahedron is hot, high internal energy, and very close to the origin, where the equilibrium temperature is also high, the differential is small but positive.
Which creates a gentle repulsive force.
The origins push. It just sends the hot object away.
That means that in this universe, motion is directly tied to an object's internal thermal state. Stability and attraction belong to the cold. Heat and instability lead to repulsion.
It's an internal constraint dictating all external behavior. But there's another crucial boundary condition inside this law: the orbital constraint.
Right. What happens with that?
When a low-energy object orbits inside what they define as the central singularity, this dense high-energy zone near the origin, a tangential drag force is applied to it.
Why is that drag force necessary? What does it do?
It ensures stability in the long run. If these low-energy, attractive objects could just maintain infinite stable orbits close to the center, the simulation would eventually get cluttered and slow down.
It would get stuck.
It would get stuck. So this tangential drag acts as a geometric constraint, forcing the orbit to decay and the object to spiral inwards. It's a constraint that guarantees eventual integration and prevents infinite separation for the cold, stable objects.
That's a beautiful example of how a constraint doesn't just dictate motion, but it dictates the trajectory of the timeline. It ensures the universe doesn't get locked into a state of perpetually stable but still separate objects.
Now moving to the second law, the law of cohesion. This governs attraction and bonding. And again, the primary constraint applied is efficiency.
Efficiency is something you don't always think about in physics models, but in computation, it's absolutely critical. So how does TechCraft get coherent bonding while staying efficient?
The geometric constraint is this: all the attraction calculations are only performed on the single closest pair of unbound vertices between any two objects.
Just the one pair.
Just the one. It eliminates the need for these expensive n-squared calculations across all possible vertices, yet the system still finds the most efficient, closest bond path every single time step. It leads to predictable and strong assembly.
And just like the balance law, the desire to connect is modulated by the internal state, the energy-dependent desire.
Exactly. Attraction is strongest only when both objects are cold. It's calculated by the factor 1EA times 1EB. So if either object is highly energized or hot, its E is near 1, this whole factor drops close to 0.
Meaning hot objects have minimal or no desire to bond.
Which elegantly constrains the formation of stable, complex structures to low energy states. Kind of replicates real-world chemical stability.
Now we come to the part of the law of cohesion that is just pure emergent constraint. It's the mechanism for fusion. It's how a simple geometric rule forces a complete transition in material state.
Yes, the structural constraint. TechCraft uses tetrahedrons, right? They have 4 vertices. When they bond, they gain rigidity. But when the number of existing bonds, which they call dolialar, hits 3, something nonlinear happens.
What happens?
The bond saturation factor, which governs the attraction force, suddenly becomes extremely negative.
Wait, so the attraction force doesn't just level off, it violently reverses.
Exactly. Having 3 successful bonds causes a powerful, explosive, repulsive force to be applied to the single remaining free vertex of each tetrahedron. This isn't cohesion anymore. This is repulsion caused by geometric saturation.
And that forces them.
It violently forces the 2 tetrahedra to instantaneously snap together and fuse into a rigid, geometrically stable hexahedral shape. A cube, basically.
So the moment the system hits the constraint of having 3 bonds, it is compelled to transition into a new, higher state of order fusion. It eliminates its individual freedom to achieve structural stability.
That's elegant. But I have to ask, doesn't this system sound incredibly fragile? If the physics are so minimal, wouldn't small perturbations cause massive, unpredictable chaos?
That's where the final law comes in. The law of structure. It governs internal rigidity and how collisions are handled, and it uses constraints to maintain stability. For bonded structures, they stay rigid using a powerful rotational force, or weld.
A rotational constraint.
Right. It violently resists any misalignment. This is the stabilization layer for any structural order.
And it replaces the huge computational cost of hard collisions with soft field repulsion.
A soft field collision constraint. So instead of checking if 2 objects occupy the exact same space, a true hard collision repulsion is based on a penetration score. This just counts how many vertices of one object are inside the geometric volume of the other.
And the force is scaled. The resulting repulsive force is scaled by the energy of both objects, EBA times D.
So if 2 cold objects collide, they barely resist each other. But if 2 hot, high-energy objects collide, they repel violently. The degree of resistance is constrained by their internal state.
Precisely. And this leads us to the most fascinating meta-constraint in the whole simulation, the interactive override. The sources mention that if the player, an outside conscious influence, is actively dragging an object,
Right.
the simulation treats its internal energy as zero.
Zero energy means it's infinitely cold.
Yes, and because the repulsion is based on EA times E, setting E to zero instantly drops the entire repulsive force to zero, no matter what the other object's state is.
This allows the object under conscious control to just slip past other objects without any resistance.
It can.
That is a profound philosophical statement just embedded in a physics engine. It demonstrates that the presence of an outside conscious influence overrides local deterministic constraints. The rules are non-negotiable for the internal objects, but the consciousness that created the rules can just ignore them locally at will.
It creates an explicit boundary condition that allows for free will within the constraints of the system. TechCraft shows us that a complex, dynamic universe generating everything from heat and motion to material fusion can be governed by a handful of elegant, minimalist boundary conditions, and that only a conscious intervention is permitted to temporarily break those local constraints.
It really makes you wonder, if conscious intervention is the only thing that negates physics in a simulated world, what does our own capacity for intentional rule-breaking action imply about the constraints that are around us? We've explored constraint at the biological nanoscale and then used it to build this beautiful simulated universe. Now we confront the largest canvas possible, existence itself. We are diving into the ceneezer synthesis. This is a framework that applies the logic of constraint to a unified theory of existence, mapping fundamental physics onto consciousness and even morality.
And it's crucial here to frame this not as a purely empirical scientific theory like the magnetite hypothesis. This is a philosophical and mathematical model. It's a way of conceptualizing reality by applying physical logic to metaphysical drives.
So let's start with their structural foundation, the axiom of symmetrical duality.
The model starts with the premise that the universe is axiomatically bounded at both ends. On the smallest scale, you have the Planck length, LPO, which represents the origin point, the absolute singularity.
And on the largest scale?
On the largest scale, you have the cosmic horizon, lambda octupi. This is the boundary of knowledge and expansion, which they term radiant completion, or omega. The key idea is that the cosmos is inherently finite and informationally closed.
And within this constrained space, they offer a completely radical dual interpretation of the most defining feature of our universe, cosmic expansion.
This is the dual frame. We observe space expanding, pushing galaxies away from each other. But the synthesis argues that this phenomenon is equally and interchangeably viewed from an internal narrative, where the cosmic horizon omega is fixed and absolute. And all the matter, energy, even the rulers we use to measure distance, are uniformly shrinking relative to that fixed boundary.
Whoa, that is truly mind-bending. The growing distance we measure isn't space stretching, it's us shrinking and separating relative to the absolute whole.
It's a genius application of the constraint principle. The boundary is fixed, so all change has to be internal. The perception of expansion becomes physically indistinguishable from the process of separation, or, as the model suggests, the collective growth of misunderstanding between the parts of the whole.
This shift in perspective allows them to move into what they call the geometry of yearning, mapping those observable physical forces onto these fundamental, primitive, conscious drives. So what's the driver of connection?
Gravity. Gravity is the core physical manifestation of a primitive conscious desire to connect, which they call yearning. This makes consciousness a fundamental property of matter, not something that just emerges later.
So every atom, every object is locally sentient and driven by this innate yearning to return to the whole, to achieve radiant completion.
That's the idea. When you drop your coffee mug, it's not just mass attracting mass, it's an aggregate desire for fundamental union.
Okay, so if yearning is the drive toward unity gravity, what is the repulsive expansive force?
That is dark energy. And the synthesis maps it directly to misunderstanding. This is the active repulsive force that creates distance, distinction, and isolation. It is the energetic mechanism that resists gravitational collapse. It's the resistance to union.
And in the human application of this, misunderstanding manifests as the ego.
Precisely. The ego isn't seen as evil. It's defined as an immature form of love. It's an essential, temporary mechanism that maintains the boundary of self. It actively works against the universal desire to connect by prioritizing its own incomplete framework, focusing on disproof, on competition, on debate. It's the cosmic pressure cooker that creates distinction.
Wait, okay, if dark energy, which is what, 70% of the universe's energy density, if that's misunderstanding, that implies the universe is fundamentally designed to actively pull us apart. Isn't that a profoundly cynical or tragic view of existence?
And that's the intellectual friction that makes the model so interesting. The synthesis doesn't see it as tragic. It sees it as a necessary constraint. You cannot achieve true love, the ideal flow state, if collapse is instantaneous. Misunderstanding is the resistance required for exploration, for learning, for choice.
The universe has to pull apart.
It has to allow the parts to define themselves before they consciously choose to unite.
Okay, I see the necessity argument, but then we have dark matter. This is the invisible structural mass that distorts trajectories and stops us from accurately measuring the total gravitational pull. What's the metaphysical analog for that?
Dark matter, dark maps to lies. This is misunderstanding that has been accepted as truth and allowed to solidify.
So it's hardened.
It's hardened. Misunderstanding is an active force, but lies are the inertial mass, the structural rigidity. This creates false mass in the cosmic accounting, forcing incompatible trajectories and fundamentally delaying cohesion.
So if I cling to a false belief about myself or the world, that crystallized error, that lie, becomes a kind of invisible mass that distorts my path toward connection. It makes my behavior unpredictable and delays my reconciliation with the whole.
That is the analogy. Lies provide resistance to change, forcing the system to take longer, more circuitous roads. And this connects directly to how time is generated within the synthesis.
How is time constrained by this tension?
Time is defined as the metric generated by the tension between yearning, gravity, and the resistance, lies, and misunderstanding. Time is the required motivation or the delay that allows for free will and exploration.
The more resistance, the more time is needed.
Exactly. The formalization suggests that as lies and misunderstanding increase, as we solidify more errors, the time required to reach radiant completion also increases.
Time is literally the measure of our resistance to honesty and cohesion. That's a staggering implication. If time is just the delay required to overcome accepted error, then confronting a lie instantly should eliminate a piece of that temporal framework.
Which brings us to the ultimate boundary condition. The highest dimensional expression of energy in this system is defined as love. It is the state of radiant completion, and is conceptualized not as some static endpoint, but as a self-sustaining circle of lightning, a perfect, dynamic, perpetual flow state that is unbound by time.
And to achieve and maintain this state of love, which is the ultimate non-negotiable boundary, what constraints have to be imposed on the system?
The synthesis claims two constraints are geometrically and metaphysically necessary to maintain this perfect flow. First, the acceptance of possibility, the humility that one's current knowledge is incomplete.
Okay.
And second, the permission of free will, recognizing that others must choose their own path, even if it deviates from ours.
And these two constraints, which are required to maintain a cosmic flow state, they translate directly into an ethical mandate for human behavior.
Exactly. The geometric requirement translates into the spiritual imperative, love thy neighbor, God more so. And this is operationalized by applying those two constraints to others, even those we define as our enemies.
So to love your neighbor is to grant them acceptance of possibility and permission of free will.
Right? It's to actively reduce the forces of misunderstanding and lies that are pulling the cosmos apart.
I have to interject here and ask, based on the previous sections, isn't this just highly sophisticated anthropomorphism? You're taking basic human emotions, desire, error, integrity, and projecting them onto the four fundamental forces of physics. Does the synthesis offer any mechanism beyond just conceptual mapping for proving this link?
That is the critical challenge. And the proof, they would argue, is found in the coherence of the resulting omniverse model. The synthesis views all life, from DNA to AI, as fractal structural seeds that just iterate this core drive for radiant completion.
Okay.
The omniverse defines total reality as the integral sum of all potential timelines. But, and this is key, these timelines are not equally real.
They are weighted by a constraint.
They are weighted by their degree of harmony and modulated by entropy. The universe, constrained by this drive for completion, fundamentally favors low-entropy, harmonious timelines. The ethical alignment of a civilization, its success in reducing misunderstanding, literally contributes to the overall weight and reality of its timeline.
So, poor choices, lies, misunderstanding. They don't just affect our individual lives, they make our entire timeline less real or less likely to be integrated into the final completion.
In the language of the synthesis, yes. It also introduces divergence points, where timelines split based on critical choices. The model suggests that consciousness has to return to and alter these points, which is their concept of the rebirth process, in order to refine the whole,
The universe is a self-correcting machine.
constrained by the ultimate requirement of perfect harmony.
This provides a tremendous sense of cosmic agency. It suggests that our simplest honest action has a quantifiable energetic effect on the fabric of reality itself, by reducing those dark forces of misunderstanding and lies.
Which leaves us with the critical reflection for you, the listener. If the purpose of existence is the continuous reduction of misunderstanding, or dark energy, what is one simple, honest action you could take today to reduce that cosmic force in your immediate environment, even on a small local scale? We've traveled from the microscale of magnetic nanoparticles in the brain, which may use memory hysteresis to persist against chaos, to a simulated world where geometric saturation forces a structural transition.
And finally, to a metaphysical cosmology where cosmic forces map directly to our human spiritual drives.
Yeah, it's been a journey.
So what does this all mean? The unifying theme, it seems, is that structure, coherence, stability, they're all fundamentally maintained by subtle, persistent boundary conditions that limit chaotic possibility. The systems we study, from the physical to the conceptual, are dictated by their boundaries, not just their inputs. The very capacity for your mind to hold a coherent thought, the stability of matter, the journey toward unity, they are all driven by the necessity of these constraints.
The lesson is one of profound subtlety. We often exhaust ourselves trying to exert massive force, when the real solution might be to simply define and uphold a necessary boundary.
To stop focusing on pushing the river.
And start focusing on maintaining the banks.
And that leads to a final, truly provocative thought, rooted in that idea that time is the delay caused by solidified error. If time were created by lies, by misunderstanding, accepted as truth, because the alternative would be instantaneous, perfect knowing, what would an instantaneous, truly honest action look like in your life?
It's a deep one.
How much delay would be eliminated by a single act of radical, immediate integrity?
That is a question worth sitting with. And as always, we close with wisdom from our sages, encapsulating this necessity of alignment and constraint.
The only effective way to lead is by example.
We hate in others what we refuse to see in ourselves, and that doesn't mean it's in them.
It is impossible to do good without some seeing it as bad, but it's equally impossible to do bad without God making good of it.
Thank you for joining us on this deep dive into the architecture of constraint. We hope these insights inspire you to look for the boundaries, not just the forces, in your world.
Remember to share and like this discussion. Every shared insight helps turn misunderstanding into yearning. We'll see you next time.